On to the second kind of multiplication that we see in vectors. We called it the dot product. So let's examine that a little bit. Dot product. All right. So the dot product is defined for two vectors A and B. So given some vectors A and B, which are two arbitrary vectors, they could be called C and D, they could be called omega and alpha, but basically it's an operation that's performed on two vectors. The dot product is represented in the following way. You write the vectors A and B next to each other, and in between them you put a little dot, right? And the resultant of it is a scalar quantity. A scalar quantity is what comes out of a dot product, right? And by definition, this is the mathematical definition for what a dot product yields or results in. So A dot B is defined as the magnitude of A multiplied by the magnitude of B. That result is multiplied by the angle, the cosine of the angle between A and B, right? So cosine theta AB, and you can see that A and B both have tildes underneath them, so that is cosine of the angle A and B. One of the big questions that you might have when I write this formula down is, how do you find the angle theta of AB? To obtain theta AB, let's make the tilde loop here. Yeah, to obtain theta AB, you take the vector A and B and put them tail to tail, right? So put A and B tail to tail, right? So that means if I have two vectors A and B, I should place them something like this, right? So the two tails are at the same point. Then there are two angles that exist at this point. One is this angle here, which is the smaller of the two. I'll call that theta 1. And then there is the bigger one, right? So we'll call that this one over here. Right? Let me make that clear. Sorry. This one. So that one is called theta 2. So how do you choose theta AB? Well, convention has been established, and you always choose the smaller of the two angles between A and B. So theta A, sorry, let me change the color of the pen again. Sorry, 1 second. Yeah. So theta AB is the smaller of two angles between A and B. So going back to the previous page, we should just say that we don't choose this one. We always choose theta 1. So we'll put a green tick against it, just to be clear, right? Okay, so theta 1, the smaller of the two angles, is the one that we choose. Just to be completely clear, we'll say that in the case on the previous page, in the case on previous page, it is theta 1. So that should clarify anything. We've put a tick against theta 1. We've also written explicitly that the correct theta AB, or theta of the angle between A and B, is the smaller of the two, which was identified as theta 1. Right. The dot product has some properties, just like you see in the case of vector addition, actually, and we'll just write them out. Properties of dot product. One is that it is commutative. which means that A dot B is the same as B dot A. So reversing the order of multiplication in the case of a dot product does not alter the result, because that cosine of the angle between the two does not change whether we start with vector B and sweep into vector A or vice versa, right? And the second property is associativity. It turns out that dot product is not associative, not associative. And we won't go into the proof for this, but you can just accept it as a result. Another important property is that two perpendicular vectors have zero dot product. That means if A perpendicular to B, then A dot B is equal to magnitude of A times magnitude of B times cosine of 90 degrees. But cosine of 90 degrees is 0. So that gives us as a result that A dot B is equal to 0. That's what that means. This is only in the case when two vectors are parallel to each other. So I'll write that is if A is perpendicular to B, then the dot product, if you use the formula, the definition and all of that, and you go through with the steps, you will see that the resultant of two perpendicular vectors is 0.